good morning, good afternoon, or good evening, whatever your case may be. Previously, we looked at resonance in closed pipes. Pipes we said are closed at one end. Today, we want to look at resonance in open pipes. These are the pipes which are open at both ends. Then we want to compare which of the two produces a better musical note, or which of the two produces the better harmony. Yes, so these are the open pipes. As we said, these are pipes which are opened at both ends. This one is going to be short for you. Please just give it a few seconds. So I'm going to simply use one here of a particular length L, of a length L, and let's see if you blow in air here, how the behavior would be. It's slightly different from what happens in the closed one. If you are not sure of the closed one, refer to the previous video. Just check there. You'll be able to see it. So, you see, when you blow in air, it just goes right this way, and of course the reflected one will come that way. And you realize that this is a quarter of wavelength, and this is another quarter, meaning from here to here is half the wavelength, meaning this distance is half the wavelength, ignoring the end corrections. And so we have the L equals the wavelength over 2, giving me wavelength as twice L. Keep remembering the wave equation. The wave equation, very important. So from this, we are interested in the frequency. For this case, which is the fundamental frequency. So our fundamental frequency, so you see from here, orange frequency will be out of lambda. And so therefore, our fundamental frequency is the smallest frequency. The F naught is the velocity of sound in air in this case, then divided by the wavelength, which is equal to 2 twice the length of the pipe. We can repeat this one and we say this becomes our equation 2. We want to do exactly the same. And we say, what is the next possible mode of vibration? The next possible mode of vibration, it will simply be like that. It will simply be like that. This one being the length, as we had in the previous case. And you can realize this is a quarter wavelength, this is a half wavelength, this is another quarter, meaning it is a full wavelength. So the whole of this one now becomes wavelength. Therefore, our wavelength is equal to the length of the tube or the pipe in this case. And so, what is our frequency? The F1, the next after F naught, will be the velocity of sound in air, then divided by the wavelength, which is this one. We could say this is our equation 3. That will be our equation 3. Can we check one more? Yes, we can check one more. Yeah, we can check one more, then we shall come and we prove something. Yes. For the next, now what is the next possible mode of vibration? It would be like this one, then another point where there could be a meeting kind of a point. So if I still have a pipe of still the same dimensions, and now the next possible mode of vibration would be this, and that. Yes. Then, of course, the reflected one you have something like that. And what do you realize? What you realize is that this length is equivalent to, this is a quarter wavelength, this is another quarter, this is third quarter, the fourth, the fifth, and the sixth quarters. So this is the wavelength, this is 6/4 of the what? Of the wavelength, this distance, which is of course 3 halves. So we shall have L equals 3 halves of the wavelength, and so we have our wavelength smaller, of course, equal to twice the L out of 3. Yes, and then in this case, maybe somebody will have called this one number 3. Then we have our frequency, the next frequency, which will become the velocity of sound in air, then divided by the wavelength, which is divided by this. This is 2L. Then of course the 3 will get up. Yes, and then if we have that, then we should have this one equivalent to the 3 will be up, 3 will be out of 2L. So when we have had that, and then our F2, there is something we want to find out. So I want to come back here. I get F1 divided by F0. F1 is V out of L divided by F0. F0, remember, is this very one here. Yes, F0 is this one. So if I divide it by this, I would possibly multiply by the reciprocal, which is 2L out of V. You realize that this L and this L will cancel. This V and this V will also cancel, and we will simply remain with F1 out of F0 equal to 2. This one is what has survived, giving us F1 equals, if I take this side, equals 2 F0. So meaning that the first fundamental frequency is equal to twice the original, the first overturn is equal to twice the fundamental frequency. Yes. Let's look at now this one. Do the same. F2 out of F0 is 3V out of 2L. Divided by this same F0, we shall multiply by the reciprocal, which will be 2L out of V. And so the 2L here would cancel, the V would cancel, and so we will have F2 out of F0 equaling to 3. Yes, F2 out of F0 will give us a 3, and so this would give us that F2 equals 3 F0. Yes, so if we have F2 as 3F0, what are we realizing? We are realizing that our first frequency can be in order. The first one is F0, the second one is 2F0, then the third one is 3F0. If you do the first, the fifth, and others, it will also give you 4F0, 5F0, 6F0, and etc. Therefore, here it is giving us all harmonics. It is giving us F0, twice F0, thrice F0, and etc. Unlike in the closed pipes, where it was giving us F0, 3F0, 5F0, 7F0, 9F0. The other one was giving us only the odd multiples of the fundamental frequency. This one is giving us all the multiples of the fundamental frequency. That's why the open pipes are always preferred in musical instruments than the closed ones, because the other closed ones, there are particular notes they may not give you, there are particular frequencies they may not give you, but these ones are going to give you all the frequencies, multiples of the fundamental frequency. Yes, I am doing another thing soon
finish this video, rewatch it and watch it, understand, and then watch other videos. They are coming. You do not have to forget to subscribe, and also you click the notification button so that when I upload the video, you'll be able to know that it has come for your own benefit. Thank you for this much attention, and thank you for the support you render by watching our videos here. At Back Media, we are coming out with very many other things. You soon know them. Please be blessed.